So, in this video, we're going to look at everything you need to know about algebraic fractions for your exam. This video is split into 8 parts. We're going to start by looking at simple, straightforward candidate examples like this one. We're then going to move on to examples with brackets. And then we're going to look at examples where we need to first factorize, and then factorization that involves the difference of two squares, and then factorization with quadratics, and then look at, well, how can we simplify algebraic fractions where you're adding and subtracting, and then how do you solve them to find x? And then, as always, we're going to end up with looking at the real exam questions. And just to show you the two exam questions we're going to look at, I've handpicked these two hard exam questions on algebraic fractions. So the way all my videos work, I'm going to start on the left with the example, which is I do. You are then going to press pause and have a go at the example, which is you do. And at the bottom of the slide, you can see the type of example this is. So to kick things off with this example here, we have been asked to simplify the following. So we can see that 5 goes into 10 two times. So we can say 2 at the top. And with the rules of indices, we're dividing. So we're just going to subtract the 5 and the 2. And that is cubed there. So press pause and have a go at the example on the right. And that becomes that. So looking at this one, now we've got x and y. So we're going to start off again. I like to start from left to right. So with the numbers first. So that becomes 4 because 3 goes into 12 4 times. The 3 and the 1 cancel out in x to give us x at the top. And then we are left with 5 minus 3, which is y squared. So again, press pause and have a go at the example on the right. And hopefully that's the answer you got. And then final example on this part is with negative indices. So here we have 2. And then we have x squared minus x to the power of 4, so that becomes x to the power of minus 2, and then finally we have 3, and there's just an invisible 1 there, that becomes squared. Now you can also write this as, let me just tidy that up, as that too. So the choice is yours. You can either write it as a negative indice or you can write it in this form. So again, hopefully you press pause and add a go at the example on the right. So that just becomes 0, and then x to the power of 0. Anything to the power of 0 is just 1, so we leave that out, and then that's y to the minus 2. Again, you could have also wrote this like that. So here are some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. Now, moving on, we are now looking at examples with brackets. Exact same principles apply. So 8 goes into 2 4 times, so that's a 4. And then with the, you can almost ignore, because the brackets have got the same thing inside, it's the same principle, there's an invisible 1 there. We subtract the 2, so 5 take away 1 is 4, so that's x plus 5 to the power of 4. Again, hopefully you've pressed pause and had a go at this, so that's 2x plus 4. You can put the power of 1 if you want, or you can leave it. Now moving on, now you've got to look for the matching pair, so that's x plus 3 matches up with this x plus 3 down here. These two match up, so we're going to look at the powers on them. So 5 goes into 15. There we go, 3, and then we're left with x minus 3. Again, you can put the 1 on if you want, or just leave it at that. I don't need to write the brackets at the bottom because there's only one thing left. And again, hopefully you've pressed pause and had a go at this. The two matching pairs this time are x plus 7, that's 6 take away 2. So again, here are some practice questions for you to have a go at. Here are the answers. Mark your work. Moving on, we have to factorize in order to cancel. So looking at the top, we can leave the top as it is, 2 bracket x plus 7. At the bottom, we can remove a 3, so 3 goes into both 3 and 21. We can also take out an x, and we are now left with this. And hopefully you can see straight away that that and that can cancel out, so that leaves us with 2 over 3x as our final answer. Again, on the right, hopefully you've pressed pause and had a go at this. We can factor out the 5 and the x, and then finally we can cancel that out, and we can also get rid of the x here, so that leaves us with 3 over 5. So looking at this one here, again at the top we can factor out the 6, we can factor out an x, and we can factor out a y, so that leaves us with x plus y in the brackets, and then at the bottom we have 6x cubed y cubed. In terms of cancelling here, the 6 can cancel out, we can get rid of the y here, the x here, sorry, and that becomes squared. If we get rid of the y here, that becomes squared 2. And then our answer becomes x plus y over x squared y squared. Again, hopefully press pause and add a go at the example on the right, so we can take out a factor of 10, a factor of x squared, and a factor of y. And then that becomes 20x squared y, awesome, over 30x. Now, 10 and 30 are divisible by each other, so that then becomes a 3 down here. This x can cancel out one of them there, so that leaves us with a final answer of x, y, bracket x, y plus 2 all over 3. And you can expand the brackets out at the top if you like, or leave it like this. So here are some practice questions for you to have a go at. Press pause and have a go. Here are the answers, mark your work. So moving on, we're now looking at factorization with difference of two squares. So looking at this first example here, at the top I noticed that I can factor out a 2 and an x. And at the bottom I can factor out a 2. Now what's key to spot with these examples, what's very, very key here, is to spot that the fact that this is the difference of two squares. Actually I have forgotten one thing. I've forgotten the square on there. There we go. This is the difference of two squares because 9 is a square number and so is 4. They're both square numbers. What does that mean? That means that we can write this as, so if I just rewrite that, and I've just realized I've made a mistake here, that should have a 3 there. So let me just tidy that up here. This can now be written as 3x minus 2, 3x plus 2. Because if you expand this out, you'll end up with 9x squared minus 4. So now, hopefully you can see what that's allowed us to do. That and that cancel out. This 2 and this 2 also cancel out. That leaves us with the final answer of x, 3x minus 2. Again, remember these questions, the trick is to see if you can spot the square. Again, I can see two square numbers. So the difference of two squares means two square numbers are being subtracted from each other. So that's this square number and that square number. And just as a reminder, square numbers are, so that's 1 squared, 2 squared, which is 4, 3 squared is 9, 4 squared is 16, and so on. And here we can see we have got 4 and we've got 1. And they're both being taken away from each other, so that's 4x squared minus 1. And we can write that as 2x minus 1 and 2x plus 1. Okay, so if I now rewrite this, so that becomes, well, I can factorize the top first. So that becomes that plus 1. And then at the bottom, we end up with 2x plus 1 and 2x minus 1. And now we can cancel out this, and that now leaves me with 3 over 2x minus 1. So here are some practice questions for you to have a go at. Press pause and have a go. Here are the answers, mark your work. So moving on, we're now looking at factorization with quadratics. So we are looking for at the top and the bottom. You can notice it's a quadratic because we've got an x squared term. We are looking for two numbers that multiply together to give us 6, that add or subtract to give us the positive 1. Oh, I've put that at the wrong place. So we need a minus 6, so 3 and 2. Can that get us there? Well, yes, it can. So that'll be plus 3 minus 2. And then at the bottom, we have x plus 3, then x minus 4. So those are two numbers that multiply to give us minus 12, and then add or subtract to give us the minus 1 in the middle. That and that cancel out. So that leaves us with a final answer of x minus 2, x minus 4. So hopefully you've pressed pause and had a correct example on the right. So two numbers that multiply to give us 30, that add or subtract to give us the negative 1. So we have 1 and 30, 3 and 10, 5 and 6. That looks about right. So we have x, we have 5, 6. Yep, that gives us minus 30 and the minus 1. And then at the bottom, we have 12. So we have 1 and 12, 2 and 6. Yep, that looks right. 2, 6, x, that'll be that, and that'll be that. That'll give us the negative 4. And now hopefully you've spotted that that and that cancel out. So that gives us x plus 5 over x plus 2. So now we've got the exact same thing. So, but this time the quadratic has the x squared coefficient has a number in front of it, which is fine. So if I look at this, immediately the quick thing I spot is the denominator has the difference of two squares. So that means at the top somewhere we must have one of these two. And at the top we need two numbers that multiply to give us 12, that add or subtract to give us the minus 7. And immediately I can see it's them two there, so that would be 2x squared minus 4x minus 3x plus 6. And if I factorize that, we have 2x bracket x minus 2, and then x minus 2 again. And then you can put a 3, negative 3 there. So that's 2x minus 3, x minus 2. That and that cancel out. That leaves us with x minus 2 all over 2x plus 3. Again, hopefully you've pressed pause and had a go at the example on the right. So I can see immediately the easier bit is at the bottom for me to quickly do that. So 5x minus 1. So that means at the top I should probably end up with something like 5x minus 1. So two numbers that multiply to give us minus 15. That add or subtract to give 14, 1 and 15. And that would be that. Okay, so we have 5x squared plus 15x minus 1, x minus 3. So that's 5x bracket x plus 3 and x plus 3. And then a negative 1 here. So that's 5x minus 1 and x plus 3 there. So that and that cancel out. That leaves us with x plus 3 over 3. So here are some practice questions for you to have a go at. Press pause and have a go. And here are the answers. Mark your work. So now we have got fractions where we are adding. So this is the same as normal fraction addition. You just have to make the denominators the same. So I'm going to multiply the top and bottom here by 3, the top and bottom here by 2. So the 2 comes from there and the 3 comes from there. Just to highlight that, actually. There we go. So just so you know where those are coming from. And now you'll see what these actually do. So that's 3x plus 3 plus 2x plus 4. And the denominator is just 6. Collect the like terms. Again, over on the right, the exact same thing applies. Now, there is one thing that can sting you a little bit on the right. So times 3, and then times 7, times 7. And the thing that can sting you a little bit here is the fact that there's a negative here, right? And I'm going to write this bit out. I'm not going to multiply it on the fly. So that's going to be minus, so that's going to be 7 bracket 7 minus 7. Actually, I'll write this bit out as well without the multiplication. So that's x plus 1. And at the bottom, we have 21. And you'll see why I wrote that out. So that's 3x plus 3. And this is where people get caught out. So they get the minus 7x there, and they mess this bit up. That's now a positive 49 over 21. The two negatives make a positive. So just one to watch out for. So that's minus 4x plus 50 all over 21. Here are some practice questions. Press pause and have a go. Here are the answers. And now we've got letters in the denominator, but the exact same rule applies. You want to make the denominator the same. So times the left side, top and bottom by y, and then times the right side, top and bottom by x. So that gives me 3y plus 5x all over xy. And that is it in its simplest form. We can't simplify that any further. And then on the right, now one quick way here is, well, to make the denominators the same, we just need to multiply the right side. So we have 5 plus 6x over xy. So again, exact same rules apply. So we have 4 bracket x minus y, and then we have plus 5x, and the denominators now become the same. So that's x minus y. Expand the top out because we can collect the like terms. So that gives us 9x minus 4y all over x bracket x minus y. Again, hopefully you've pressed pause and had a go at this one. So, and then times the top and bottom on the right by x plus 2. And now the denominators are both the same. Let me just tidy that up and now expand that out. And here are some practice questions for you to have a go at. Here are the answers. So now we are adding and subtracting with a quadratic. So things just get a little bit trickier, but not. It's the exact same concept that still applies here. So straight away looking at this, I can spot that there's a difference of 2 squares. And if you do spot that, it will save you quite a bit of work. Okay, so this is the difference of 2 squares. One is a square number and so is 4, and we're subtracting the 2. So if I rewrite this, now if you didn't spot that, it would have just been a slightly longer route to the same answer. Now that I've spotted that, I can notice that this has this and this already in it. So the only thing that we're missing is x minus 2 from this side. So all I need to do is multiply the left side by x minus 2 at the top and bottom. So if I do that, that'll give me 3x bracket x minus 2 plus 11x minus 2. And now all the denominators are the same. And I can just do that. Now, if you could spot that, like I said, it makes your life a lot easier. So that then gives us 3x squared minus 6x plus 11x minus 2 all over x plus 2, x minus 2. I'm going to have to zoom in here because I'll need the space. So that then, we can tidy that up. So that's minus 6 plus 11, which gives us 5x. So that's 3x squared plus 5x minus 2 all over x plus 2, x minus 2. Now, this can be simplified. Two numbers that multiply to give minus 6. So that's 1632. And it needs to give us the positive 5. So that will be that. So that will be 3x squared plus 6x minus 1x minus 2. So that's 3x bracket x plus 2, x plus 2 minus 1. So that then becomes 3x minus 1, x plus 2, all over x plus 2, x minus 2. And now I can cancel out the the x plus 2 and the x plus 2. So the final answer, if I write that here in a different color, so that's 3x minus 1 over x minus 2. So press pause and I've got the example on the right. So I can't spot any difference of two squares here. However, I can see there's a quadratic right here, and we should probably factorize that right away. So if you can write that out. In fact, I'm just going to zoom in case I do need the space like I did on the left. So that would then give us, and again, I can see straight away that makes the life a bit easier because I can spot right now that we already have this, and this is already in the denominator. The only thing we're missing in the denominator is x plus 3 on this side here. So all I need to do is multiply that side top and bottom by x plus 3, and the denominator now becomes the same. So if I keep going, 3x plus 14 plus 2 bracket x plus 3 all over the same common denominator. If I expand that out, there's no squared terms this time. Awesome. So that's 5x plus 20 all over x plus 2, x plus 3. Oh, I've just realized I made a mistake. That shouldn't be x plus 3 there. That should actually be 1. So that should be 2, which should be 16. So let me just double check that. X squared plus 2x plus 3x plus 2. Awesome. X plus 1. Yep. 2x plus 2. Yep. 5x. Yep. Awesome. And that is it. I don't think that can be simplified any further. So we'll leave that there. Here are some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. So now we are looking at solving. So we need to actually find the value for x. The exact same principles apply as usual. So on the left, we've got a fraction. We want to make the denominators the same. So we're going to multiply the top and bottom on this side by 2, top and bottom by this side on 7 to make the denominator the same. So that gives us a denominator of 14 On the left, we have 2x plus 3 minus 7 bracket x minus 2, which is equal to 2. If I expand that out, that gives me 4x plus 6 minus 7x. Now careful here, there are two negatives, so that becomes a positive 14. Divide that by 14, and that equals 2. Now if you tidy that up, that gives me minus 3x plus 20 is equal to 28. If I move the 14 over, then we have minus 3x, and we're just going to subtract the 28 from 20, so that gives us 8, and that becomes x is equal to minus 8 over 3 as a final answer. So again, the exact same on the right hand side. So hopefully you've pressed pause and gave it a go. So that then becomes, well, we're going to multiply it by 2 to make the top and bottom the same on the left, and then multiply it by 3 on the right. That gives us a common denominator of 6. So that's 10x plus 8 minus 9x minus 3. I can move the 6 over. That gives us 12. So that's going to become x plus 5 is equal to 12. And then x is equal to 17. So moving on, we now are solving and we'll need to use the quadratic formula. So this will appear on a calculator paper. So we have, again, we want to make the top and bottom the same. So we multiply the left by 1 plus x minus the right by just x. And then at the bottom, we end up with x bracket 2x plus 1, which is equal to 5. So at the top, we can collect the like terms. So that gives us x plus 1. And then on the right, we can move that over. So that's 5x bracket 2x plus 1. You can expand that out. So that's 10x squared plus 5x. And now we can move these terms over. So that's 10x squared plus 4x minus 1. And like I said, this will appear on a calculator paper. So at this point, you can just put this into a calculator using the quadratic formula. So that's a, b, and c. So that would be minus 4 plus or minus the square root of b squared minus 4 times a times c. And a here should be 10. All over 2 times a, which is 2 times 10. And then your final answer will be the result of that. So you'll end up with 2 values. And then on the right, we have exact same concept applies here. So we have 5 bracket 4x minus 1 plus 3 bracket x plus 4. We want to make the denominators the same, which they now are. So that's x plus 4, 4x minus 1 is equal to 6. Now if I expand the top out, and if I move the denominator over to the right, so that's x plus 4, 4x minus 1. And if I click the like terms here, so that's 23x plus 7. And then on the right, if I expand the brackets out, so that's going to give me a 4x squared minus x plus 16x minus 4. And if I tidy that up, that's 4x squared plus 15x minus 4. And if I expand that out, so that's 24x squared. And if I do 6 times 15, that gives me 90x minus 24. And don't forget about these. So if I move these over, that would be 90 minus 23, which gives me 67. That's 67x. And then it'll be minus 24 minus 7, which gives me minus 31. That's 24x squared. And now we're just going to put this a, b, c into the quadratic formula to get a final answer. So that would then become minus 67 plus minus square root of 67 squared minus 4 times a times c, which is minus 31, all over 2 times a. And then that would give us two possible answers out of that when you type that into your calculator. So moving on, here are some practice questions for you to have a go at. And here are the answers. And finally, we're going to look at 2 real hard exam questions. Now, if you do want to have a go at these yourself, I recommend that you press pause now and have a go. So I'm now going to go through the first one. So again, like I said before, with these, you want to spot anything that you can before you start the question. So can you spot a difference of 2 squares? Not really. What else can you see? Well, you should potentially start with factorizing this. It'll probably make your life a lot easier. So now, if you notice on this, it is on a calculator paper. So if I was to factorize 2x squared minus 6x minus 56, now that's quite a difficult factorization. Oops. I would just type it in the calculator using the quadratic formula, given it appeared on a calculator paper, and you'd end up with the answer of x is 7 and x is minus 4, which then means it must be written as x minus 7, x plus 4, and because it's got a 2 on the coefficient, we put a 2 outside. So we factorize that straight away. Now let's see what we can do with that. So if we start on the left, we have 14. I notice I can factorize the bottom. Now the KCF method, so flip that around, so that's 2x plus 3. And at the bottom, I'm just going to write the factorized answer, which was 2 bracket x minus 7 x plus 4. Okay. Now straight away, I can notice that and that cancel out. So if I keep going, just tidy that up, plus. So I now notice the denominators for both these fractions are almost exactly the same. I just need to multiply the left by 2 and the right by 3. So if I multiply the left side by, if I just write that down, multiply the top and bottom here by 2 and this by 3. And hopefully you can see how that one simple factorization right at the start has made your life a lot easier, and that is the final answer. And moving on. So with this one, I straight away can notice the difference of 2 squares. So 6x cubed all over 3x minus 12 and 3x plus 12. And the KCF method, so flip that. And I can multiply this out, and you'll see why, because I've just spotted it cancels out. So if I multiply that out, I end up with that, and that, and that cancel out, which leaves me with 6x cubed all over 2x4 bracket x 3x plus 12. And over here, now 2 goes into 6 3 times. I can cancel this x out with this. That becomes a 1 down here. So that becomes 3 all over x bracket 3x plus 12. Now, if I look at what the question's asked for, it's asked for it in this form. So straight away, I can notice this can be factorized further. So the 3 can pull out. And if you look at the answer, it wants a 1 at the top, but you can notice that this cancels out even further. So that and that just becomes 1. That's going to be 1 over x bracket x plus 4. And that is the answer there. Now, if you would like more practice on this, you can download the full worksheet on my website on the resources section. The link is in the comments below. If you would like more exam questions on algebraic fractions, you can use the question database, search for the topic that you want, and it'll show you every single exam question on that topic that's appeared, and the link will take you straight there. Again, the link is in the comments below, and do check out the rest of my channel. And as always, I'll catch you in the next one.